Much, Kat. Okay. Our next speaker is Aaron Purdy, who's going to be talking about some diving physiology.
Hi there, everyone. Yes. So I am Aaron Purdy. I am the new master's student here at with the Marine Mammal Research Unit, the aforementioned newbie in this title slide. So, starting off with the newbie, he's that guy over there. I'm from Alberta. I've had very relatively little experience with ocean environments. So I started out, I just wanted to come up with a question of what I wanted to do my research on. So I went through the literature, doing a lot of studying, and I finally came up with this. How do you science? No, obviously not. I'm looking at something a little bit more intellectual than that. Best part about this picture is that isn't even a textbook. That's a script from a musical. So, what I'm interested in is looking in the aerobic dive limit of sea lions and pinnipeds. So the aerobic dive limit is how long an animal is capable of staying underwater using only their oxygen. This is really important to help determine how long they're actually capable of foraging. So because of that, this doesn't have just connections to physiology, but also to their ecology and conservation as well. I specifically am interested in looking at what happens when pinnipeds exceed this aerobic dive limit. So they are capable of diving past this point where they are no longer using oxygen, but instead they're going to start building up lactate in their body. And this is associated with a lot of different costs. First cost, obviously, is going to be recovery time. They're going to have to stay at the surface to process that lactate in their body before they're able to dive again. If they're going to be staying at the surface for a long period of time, they're obviously going to be decreasing the amount of time they have to forage. Other costs that I'm interested in looking at are the respiratory muscle and lung function. It's possible that with an increase in lactate in the body, there's going to be some cost to the respiratory muscles. Maybe they are no longer able to work as efficiently, and therefore they're not going to be able to have as quick of a recovery. So once again, affecting that recovery time and affecting their foraging. I'm also interested in looking at some other physiological changes, particularly in the blood, possibly looking at things related to oxidative stress. So where I will be working, I'll be working out at the Open Water Laboratory in Port Moody with 4 trained Steller sea lions out there. I've just got the opportunity to go out there a little bit recently, and it is fantastic. I'll just show you kind of what the setup they have out there is. These sea lions are expertly well trained, and we are capable of manipulating their voluntary dives by providing fish at depth down to their relevant foraging depths. And then when we want them to come back up, we stop feeding them, and they will come back up into the surface, and they'll surface in this respirometry dome, where we'll be able to measure their metabolism. So my study plan, what I'm hoping on doing is 2 main things. First one is defining the aerobic dive limit. The aerobic dive limit actually hasn't been specifically measured in many species. It's only been measured in 5 marine mammals in total, only 2 pinnipeds, I believe. And so that's because it's very difficult to actually get these blood samples from these animals, and that's the only way of measuring this aerobic dive limit. Luckily, with the trained sea lions that we have at open water, seeing that they're so expertly trained, I'm going to be able to get some voluntary blood samples and finally define what the aerobic dive limit is. There have been many different calculations and estimates of what this dive limit might be, and this will be able to help kind of finalize as to what it actually is. How we'll be doing that, manipulating the dive duration with food provided at depth, and then using a combination of respirometry and voluntary blood samples. The other thing that I'm interested in looking at, as I said before, is the cost of exceeding this aerobic dive limit, specifically in these three different things: the recovery time, the respiratory muscle function, and their blood physiology. I haven't been able to get out there too much, but I'm hoping that I will get a lot of time to spend with these sea lions. I have lots of people to thank and lots of people I will be thanking in the future. And if anyone has any questions, feel free to come ask. Yep. Yeah, so question of what are some of the potential things I'd be looking at in the blood physiology. So there are other metabolites that might be building up in the body through catabolism and things like that, and also possibly looking into antioxidants as well that shows that sign of that oxidative stress. Any other questions? Awesome, thanks so much.